The overall goal of this experiment is to observe the effect of rotation on a gravitationally unstable system comprised of a dense fluid overlying a less dense fluid.
This method can help answer key questions in fluid dynamics, such as how the stabilizing effect of rotation competes and interacts with the destabilizing effect of gravity. This technique's main feature is the ability to create a stable, rotating two-layer system and then use a magnet to manipulate the effective weights of each layer, triggering the instability.
This is the apparatus used for the experiment. The principal visible components are a rotating platform for the experimental tank, a copper cylinder that supports it, and a room temperature Bohr superconducting magnet. The cylinder descends into the bore of the magnet in a 1.8 Tesla magnetic field. This schematic provides additional details of the arrangement. The rotation of the platform is produced by an off-axis motor that turns a slip bearing with a keyhole orifice. The copper cylinder is attached to the key-shaped drive shaft and descends under its own weight when the holding pin is removed. The complete setup includes the lighting and a remote-controlled camera to capture images. With the tank in position on the platform, move the drive shaft to its lowest position. Ensure the video camera will have a view of the experiment that is in focus and appropriately lit. To prepare for the experiment, place the platform and copper cylinder in their highest position. Lock the cylinder in place with the holding pin. With everything else set, remove the tank to prepare it for the experiment. At a lab bench, begin to prepare the liquids for the tank. For the dense layer,